Alright, so welcome to lesson 5.5. This is about functions and inverses. So what we're going to do is we're going to perform function operations, and we're going to find the inverses of functions and talk about what the inverses of functions are. This is going to seem a little weird because what we're doing today doesn't really seem to have any bearing on what we were doing the past couple days, but it actually does, and we're going to tie it all together in next lesson, which is the last lesson of the unit. So let's go ahead and get started and talk about functions. What's helpful to think of is it's helpful to think of a function as a machine, and that machine does things to numbers. So we have a number that comes in, and the machine performs some operation on that number, and something different comes out, just like in a factory, right? You take your raw materials in, you get a final product out. So if you take a 10 in, we're going to get something different, 26.2, and if we bring in a 15, we get something just. But you see, the point is that something comes in, something different comes out. So instead of trying to guess what the numbers are, it's easy to write a rule that tells us exactly what that machine is doing to the numbers. So we often write functions like an equation. So something like y equals 4 minus x squared, which we'd have here is the x would be what comes into the function, and the y is what gets spat back out. Another way to write that is by using function notation. So instead of y, we use an f with the parentheses and x. And what this means is that f is a function of the variable x. So when you see that, you'd say f of x. So that's telling us this is the variable that changes in the function, rather than just putting a y for the output. It tells us where the output is in relation to the input. So one thing we can do with functions is we can add or subtract them. So if I have two functions, one is f of x equals 3x plus 8, and the other one is g of x equals 2x minus 12, something I can do is add them and subtract them. So I'm going to find those. So I'm going to find f plus g of x, and what f plus g of x, that's a shorthand of writing f of x plus g of x. And so that's exactly what I'm going to do. F of x is 3x plus 8, and g of x is 2x minus 12. Whenever you do these kind of problems and you're subbing in functions, it's really important to put the parentheses around them, because that may or may not make a difference. After you plug them in, you can see if it makes a difference. And in this case, you can see that since neither parentheses has anything in front of it and it needs to get distributed, then you can just get rid of the parentheses altogether. So we have 3x plus 8 plus 2x minus 12. At this point, we can combine like terms. We have 3x plus 2x, so that's going to be 5x. And we have 8 minus 12, and that's going to be negative 4. So when I add f plus g of x, it equals 5x minus 4. I perform a similar thing if I'm doing f minus g. So I do f of x minus g of x. Now this is where it gets important that you put in the parentheses. Because if I have 3x plus 8 for f and 2x minus 12 for g, this time I can't just get rid of the parentheses, because that minus sign means that I have to distribute that minus sign, distribute negative 1, to both terms in the second parentheses. So what I have now is I have 3x plus 8 minus 2x plus 12, because negative 1 times negative 12 gives me positive 1. Again, I combine like terms. This time I have 3x minus 2x, which is x, and I have 8 plus 12, which is 20. So this is x plus 20. Something else we're going to do with functions is we're going to multiply them together. So if I have f of x is x squared plus 1, and g of x equals x plus 1, and I want to find f times g of x, same trick. That's going to be f of x times g of x. I put them in parentheses again. I have x squared minus 1 and x plus 1. I FOIL those two together because they're both binomials. I get x to the third plus x squared, that's the outer terms, the x squared times 1, minus x, that's negative 1 times x, and minus 1, because that's 1 times negative 1. The other thing we're going to do with functions is called compositions. Now, a composition is what you get when you plug one function into the x of another function. So they're going to look like this. We have f of g of x is how you'd say them, both of them. It's really more obvious on the left-hand side that what you're doing is you're plugging g of x into f. But the more common way to see it written is the second way. That looks like fog x. That's f and the little o for of, and a g for g of x. So it's f of g of x. And in both cases, what you're doing is you're plugging g into f. So as an example, we have f of x is x minus 2, and g of x is x squared. So what I'm going to do here, I want to find f of g of x. That means I'm going to plug g into f. So f is x minus 2, but I'm going to replace that x with a g of x. So I have f of g of x equals g of x minus 2. But I don't have to leave it like that because I know what g of x equals, and in this case g of x equals x squared. So I would plug that in. That gives me x squared minus 2. And remember, every time you plug in, make sure you use parentheses because that might make a difference or it might not. In this case, it does not. So f of g of x is x squared minus 2. You see, I didn't add or subtract or in any way append the g of x to the f of x. I plugged the g of x into the f of x. And that process is going to help us when we have to find or at least test for inverses. Now we're going to move on to inverses, since that is a good segue. Now what an inverse does is an inverse is a function that gets paired with an original function. So a function can have an inverse, kind of like a word can have an opposite. And what an inverse does is it does the opposite of what the function does. So where a function takes an input and puts out an output, an inverse undoes that. It takes the output of the original function, and the inverse's output is the same as the input of the original function. For example, if I put a 5 into the function and I get 25 out, then putting a 25 into the inverse will give me a 5 out. So you can think of the inverse as reversing the actions that a function took. Okay, so here we have two functions that are obviously inverses of each other. Just imagine you plugged something in. If you plugged something into f of x, which meant you subtracted 300 away from it, and then you moved its answer back into g of x, that means you added 300 back, you would clearly get back the same thing you put in. So by intuitively seeing two functions that are clearly inverses of each other, we can then see what happens when we composite these functions together, because that's what we're going to do when we test for inverses. So I'm going to composite. I'm going to plug in the x minus 300 from f of x into the x of g of x. Okay, so that's going to be x minus 300 and then plus 300. And when you see that happens, that means you're going to get the 300 going to cancel out, and you're going to be left with just x. So x is what you get. So that's going to be our benchmark for whether things are inverses of each other or not. And that benchmark is going to be whether or not, when you composite the functions together, when you plug f of x into g of x or g of x into f of x, you will get back just x. That's what we're looking for. That's what we're looking for. So they're inverses. Okay, that's just another way to say if you plug f of x into g of x and you get x, then they're inverses. If you get anything else, they're not. Here's another example. Here I have 2x and x plus 2. So let's plug in. We're going to plug in the x plus 2 into 2x. So the x plus 2 replaces the x in the 2. And remember to use parentheses or you will not get the right answer. So in this case, when we do that, we have 2 times x plus 2. We can distribute, and we'll get 2x plus 4. But either way, now we're not simplifying. That's it. That's all we can do. It's 2x plus 4. So I know that since I did not get x when I composited those functions together, then that means they're not inverses, and they never will be. Okay, there's one for you, some for you to try. Another thing to do is, now instead of having two functions and trying to see what's the inverses, you're going to find the inverses. So the trick to this is you first, instead of writing f of x, you just write x. You just write y equals. Then what you do is you switch the x and the y, because remember the difference between inputs and a function, its inverse is that the inputs and outputs are switched. So we'll switch the inputs and outputs. So now we have x equals 7y minus 5. But in order to be back into a function, we have to get y by itself. So we'll just use algebra to get y by itself, which means we add 5 to both sides, and that gives us x plus 5 equals 7y. And we divide both sides by 7 to get the y by itself. So that gives us x plus 5 over 7 equals y. And that means that x plus 5 over 7 equals the inverse function of x. And that's what the little negative 1 power after the f indicates, that this function is the inverse of f of x. Okay, there's one for you to try, or we'll do that in class. The answer you should get is the square root of x plus 8. Because remember, to get rid of a square root, you have to find square root. All right, that's the end of the lesson. So here's the homework for you to do. I'll put the pages on the Edmodo, and I'll see you in class next time.